No one's watching the moon like NASA. While the headlines focus on Mars and SpaceX and Elon Musk's every move, a quieter mission is unfolding in the background. One that's older, slower, but just as critical. NASA isn't trying to go to the moon. It's trying to stay there. And if it succeeds, it won't just be the first permanent presence on the moon, it'll be the beginning of something far bigger. A foothold in deep space, a forward base for Mars. A new definition of exploration, not as a journey, but as a settlement. But why now? The moon has always been there. We landed there more than 50 years ago. Apollo 11, Neil Armstrong, one small step. But we left. And for decades, we stayed away. Because getting there was hard, staying there was harder. And back then, it didn't feel urgent. Now it does. Climate pressure, political tension, global competition, and a growing realization that Earth might not be enough. The moon is close, familiar, and rich with potential, resources like water ice, scientific access to the early solar system, and most importantly, a test bed for habitats, for power, for life. NASA isn't going alone. It's part of a growing coalition of space agencies and commercial partners. But it's leading something called Artemis, the most ambitious moon program since the 1960s. Artemis isn't about flags and footprints. It's about building infrastructure, launch systems, lunar rovers, power grids, communication networks, even architecture. And the plan is already in motion. It starts with launches, big, heavy, complicated launches. The Space Launch System, SLS, NASA's most powerful rocket, is designed to carry astronauts and cargo beyond low Earth orbit. Paired with the Orion spacecraft, it forms the backbone of NASA's Deep Space Transport System. SLS launched successfully in 2022 with the uncrewed Artemis I mission. The next step, Artemis II, a crewed orbit around the moon. Then comes Artemis III, the first human landing on the lunar surface since 1972. But this time, they're not going to plant a flag and leave. They're going to test equipment, stay longer, move further, and prepare for something more permanent. NASA calls it the Artemis Base Camp. It sounds simple, a base on the moon, but the logistics are staggering. You need power, shelter, oxygen, radiation protection, food, water, communication, medical supplies, mobility, all in an environment with no atmosphere, massive temperature swings, and micrometeorites moving faster than bullets. So NASA's approach is modular. Test first, build slowly, rely on partners, use local resources. NASA's vision for Artemis Base Camp isn't a single structure, it's a system, a collection of modules, systems, and vehicles working together to support long-duration lunar missions. The first phase involves deploying a small surface habitat, solar power units, and a pressurized rover. Each of these components is being designed to function in the most hostile environment humans have ever tried to live in. The habitat itself isn't meant to be large. Think of it more like a high-tech camper than a building. But it's enough to support 4 astronauts for up to 30 days. It'll have workstations, life support systems, radiation shielding, sleeping quarters, and emergency redundancies. The walls may even use regolith-based shielding, lunar soil packed around the structure to block harmful radiation. Power is another major challenge. On Earth, we take electricity for granted. On the moon, every watt counts. Solar arrays will be the primary source of energy, supported by batteries and potentially fuel cells for nighttime operations. because one lunar day lasts about 14 Earth days, followed by 14 days of darkness. Energy storage and efficient usage are critical. NASA is also investing in mobility. Astronauts need to move, not just walk a few meters, but explore kilometers of terrain. That's where the Lunar Terrain Vehicle, LTV, comes in. It's a small, unpressurized rover designed for short-range trips, similar to the Apollo-era lunar rover, but future missions will require more. Enter the Habitable Mobility Platform, a pressurized rover that astronauts can live and work in for up to 45 days while exploring remote parts of the moon. Think of it as an RV for the moon. It allows astronauts to work without spacesuits for long periods, conduct science experiments, and sleep comfortably while traveling across the lunar surface. Communication is another pillar of the plan. Unlike Apollo, Artemis missions will require constant data links between astronauts, satellites, surface systems, and mission control on Earth. That's why NASA is developing LunaNet, a lunar communication and navigation network that combines satellites, ground stations, and surface relays. This will allow real-time voice, video, telemetry, and even internet-like access on the moon. But there's one resource more critical than any other: water. Water is life. It is